This is a quick video to talk about metric conversion, so just metric only. So in the metric system, there are many different prefixes. The prefixes run from really big to really small. Mostly we're concerned with the ones in the middle of the range. So if the middle is set as where our base unit is, the base unit could be gram or volt or joule or liter or Newton or whatever unit we're talking about. And we're mostly concerned with the units that are a bit bigger, so 10 times bigger, 10 times bigger, or 100 times bigger, or 1,000 times bigger than that unit. Like if it's deca, we're talking 10 like decade, 10 years in a decade. Kilo, 1,000, like 1,000 grams in a kilogram. Or the ones that are smaller, like 10 times smaller, 100 times smaller, or 1,000 times smaller than our base unit. So like 1,000 millimeters fit into 1 meter. 100 centimeters fit into 1 meter. 10 decimeters fit into 1 meter. So we can look at these by the different ways we've looked at here. So we have the prefix names, kilo, hecto, deca, base, deci, centi, and milli. We have the abbreviations, which are KH, DA, nothing, D, C, and M. And I want to make a note here. Upper versus lowercase really matters in these prefixes. For example, M is milli, which means 1,000th, and M is mega, which means 1,000,000. The difference between these two is a factor of 1,000,000,000. Upper and lowercase is something to watch out for sure. The fraction here is a kilo is 1,000, 1,000 over 1. Hecto is 100. Deca is 10. Base is just one of that unit. A deci, whatever, is 1/10 of it. A centi is 100th of it. And a milli is 1,000th of it. If we had a unit for like length, we would be kilometer or hectometer or decameter, meter, decimeter, centimeter, millimeter. So the suffix here, the unit stays the same, meter, meter. But what changes is the prefix, kilo, hecto, deca, nothing, deci, centi, and milli. If it was volts, we would put V for volt, but keep the prefixes the same. If it was joules, we would put J for joules. If it was liters, we would put capital L for liters. If we're doing scientific notation, which is something you may or may not have used, we'll talk more about that probably in Math 10C, but it would be times 10 to the 3, which just means 1,000, or times 10 to the 2, which just means 100, or times 10 to the 1, which just means 10. This gets nothing. Times 10 to the -1, which means divided by 10. Times 10 to the -2, which means divided by 100. Times 10 to the -3, which means divided by 1,000. So from converting from metric to metric, we start with our initial unit, the starting unit. We want to go to our desired unit, or our desired prefix. And if I want to go from kilometers to meters, I would just count how many steps. So I'm going 1, 2, 3 steps. If I'm writing them out in this order, then that's 3 steps to the right. So I would move the decimal 3 steps to the right. If I wanted to go from meter to kilometer, I would go 1, 2, 3 steps to the left and move the decimal 3 steps to the left. We'll do some examples of that. A note here before I forget. If you have square units, you got to do that conversion twice. Once for length and once for width if it's an area measurement. If it's a cubic unit, like for volume, you'd have to do that 3 times. So the exponent tells you. So if it's like centimeters squared, that 2 tells you to do the conversion twice. If it's centimeters cubed, that 3 tells you to do the conversion 3 times. Another way to do this that some people like is to use a chart. So if we have a number that we're starting with here, like 3.72 kilograms, I would look for kilo. I would put my decimal right there. And I would write out my number, 3.72. That's 3.72 kilograms. I know it's kilo because that's where the decimal is. If I wanted to convert it to another unit, say I wanted to convert it to just grams, well, I would find grams and I would put my decimal point there. If there's any blank spots, I fill them in with a 0. So 3,720 grams is the same as 3.72 kilograms. If I wanted to convert it not to grams, but maybe to milligrams, well, I'd put the decimal right after milli and fill in any missing zeros. And there we have 3,720,000 milligrams is the same as 3.72 kilograms. If we had some other number we wanted to do this with, if we wanted to do this with, I don't know, 762 centiliters. The decimal goes right after the 2, right? If we can't see it, that means it's after the last whole number. So centi would be there. I'll do this in black. I think that's showing up better. Centi would be there. And I would write 762 centiliters. If I wanted to change 762 centiliters into liters, well, my units aren't grams anymore, I guess. If I had it in liters, liter, 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 all of these are L's, then I would just need to find liter, put the decimal there. So that's 7.62 liters. If I wanted to change it to milliliters, I'd put the decimal there and fill in the 0, 7,620 milliliters. If I wanted to change it to kiloliters, I'd put the decimal there, and I would fill in any missing zeros, 0.00762 kiloliters. This graph method works really well for metric, to metric conversions only. You can also use unit fractions, and I'm going to make another video today about unit fractions that I'll put up at the same time. Unit fractions, also called dimensional analysis, work for everything. It's what I use all the time. But these methods here, by just counting the steps or making a chart, some people like to put like lines in the chart so that things are clearly delineated. It's not a bad idea. That works too. So I'll put up the unit fractions video right away.